Hello and welcome to Vodcast 15.3. In this podcast, I will overview the nebular theory. The nebular hypothesis suggests that all bodies in the solar system formed from an enormous nebular cloud consisting mostly of hydrogen and helium. Our solar system condensed from a rotating cloud of interstellar gases known as a solar nebula. About 5 billion years ago, that nebula started to contract, very likely due to a shock wave caused by a supernova explosion. And as that spiraling nebula contracted, it gained speed. In fact, we see this very same phenomenon when ice skaters pull their arms in towards their bodies. In doing so, their spin rate will increase. Now with that contracting cloud of gas and dust, most of the material collected at the center and formed what's known as a Proto Sun. The Proto Sun is basically the sun just before nuclear fusion starts. The remaining material formed a flattened, rotating disk. And that matter in the disk cooled and collided, forming asteroid-sized objects known as planetesimals. It's worth noting that at this stage in the formation of our solar system, it was a very violent atmosphere. Now let's focus on the formation of planets. The formation of protoplanets began to occur when asteroid-sized objects collided to make larger bodies. So you can imagine all those planetesimals lumping together through a process that we call accretion. And over a very long period of time, the planets started to take their shape. As the protoplanets formed, the materials that composed them began to separate. Your really dense metallic elements, such as iron and nickel, would sink towards the center of the planets. And the lighter elements, such as silicate minerals, oxygen, and hydrogen, would migrate towards the surfaces. This is that very important concept of density. Objects with higher densities tend to sink, and objects with lower densities tend to float. And during planet formation, the differences in densities between materials played a major role in where those materials ended up. In fact, we call that whole process chemical differentiation. When considering the inner planets, both Venus and Earth were able to retain atmospheric gases due to their surface gravities. And to this very day, both Venus and Earth have relatively thick atmospheres. Now in the outer solar system, where the temperatures were significantly cooler, the Jovian planets collected a high percentage of ices and gases. At this point, I'd like to show you a 3-minute video that does a great job of overviewing the nebular theory.
Our solar system is the region of space which falls within the gravitational influence of our Sun. The solar system is thought to have begun forming about 5 billion years ago from a giant spinning cloud of gas and dust. The core of this cloud grew under the influence of gravity and became denser and hotter. As material fell towards the growing core, the cloud increased in speed and flattened into a giant spinning disk. Eventually, the increasing temperature generated enough energy to trigger nuclear fusion. This fusion marked the birth of our Sun. The lighter gas was swept far out into the solar system, leaving heavier, rockier material and metallics with high melting points nearer the Sun. Molten metal and dust particles stuck together to form clusters, which in turn stuck together to form rocks. Mutual gravity caused these rocks to come together, eventually to form planets. In the hot inner regions of the solar system, rocky planets with metal cores were formed. In the colder outer regions, things were different. Further from the Sun, temperatures dropped. Water vapor condensed and turned to ice. This ice, combined with the vast amounts of gas blown away from the Sun, meant there was a lot more material here than in the inner regions. As huge cores of ice and metal grew, the gases swept away at the Sun's birth were attracted through gravity. When the accretion of most of the ice and gas was complete, we were left with the gas giants. The solar system as we know it is around 4.6 billion years old. It's looking pretty good for its age.
So in summary, the birth of our solar system began as dust and gases started to gravitationally collapse, and we call that cloud of gas and dust a nebula. Then the nebula began to contract into a rotating disk that was heated by the conversion of gravitational energy to thermal energy. Over time, the cooling of the nebular cloud caused rocky metallic material to condense into tiny solid particles. And then, during a very violent period of our solar system's formation, repeated collisions caused the dust-sized particles to gradually coalesce into asteroid-sized bodies. And as this process occurred over a time frame of a few million years, these bodies eventually accreted into planets. So the solar system, as we know it, evolved from a nebula, hence the term nebular theory. Okay, that concludes this video podcast. In our next Vodcast, I will provide a general overview of the solar system, and then from there, we'll briefly tour all of the planets.